So in the last video, we looked at how to clean our data. One thing I didn't mention at the end, though, is that you can save the new data if you want. First of all, you want to save your do file. So if I have my do file saved, then I can just run it the whole thing again, and it'll get me back to where I was. So I actually very rarely save a new data set, but let's say I wanted to save that new data set with all my clean variables, I could just write save and then give it a name, CES edited, and then always do replace. That way every time you run it, it'll replace it. So essentially you can see that I created this new data set. You don't necessarily have to though, because you will always have your do file and it runs so quickly you can just run it at the beginning. But just FYI, I didn't mention that. And also you save your do file. Okay, so let's do some just summary stats. So let's just remind ourselves we had created these 4 variables. So here's these 4 variables that we had created. So we created this government effective, political interest, age, and voted. So let's say we just wanted some basic summary statistics. Oh, somehow we got on cap locks. I'm gonna write sum for summary statistics, and it'll show me for each variable that I list right after it. It'll tell me the number of observations, so the number of people who had responded to that question. It'll tell me the mean, which may or may not mean anything. Remember, government effectiveness was a categorical variable, so the mean doesn't really mean anything because they just randomly assign numbers to each of the response options. Standard deviation, again, kind of meaningless here. The minimum and the maximum, which again, kind of meaningless. For interest, however, that was a variable on a 0 to 10 scale. We have almost 10,000 observations. Our mean is 6.669614, or so. Usually 2 decimal points is just fine. So let's say 6.67. So here it actually means something. So it means that the mean or the average political interest score or response was 6.7, meaning, you know, it's tending towards more political interest. Of course, we know that people who respond to these sorts of surveys tend to be more interested. It gives you the standard deviation or the mean to the mean. It gives you the minimum value, which is 0, and the maximum value, which is 10. This is also a really good way to just kind of check that you cleaned everything correctly, because let's say I had like a 99 here, I'd be like, wait a second, that makes absolutely no sense. And I go back and maybe I find out that they put 99 means I don't know, and I need to get rid of that. So I always sum all my variables, and by sum I mean summarize all my variables, just so I know that I did it all correctly. Age, so this has a very large number because everybody got asked that, no matter if they were in pre-election, the campaign period survey or the post-election survey. And so everybody got asked that. So that's why we have lots of observations. Everybody will tell you their age. Our mean age being 48.69, so almost 49. Standard deviation, mean to the mean, between 18 and 99-year-olds, which is good because if we had like a whole bunch of like 120-year-olds, I'd be concerned. Voted. So it's a binary variable. A lot of people were asked that because remember we combined our 2 samples. The mean is 0.92, which means 92% of people said yes. And this is why I did it 0 as no, I didn't vote, or I am assuming you didn't vote, and 1 being yes, I voted, because then I can just see the number 0.92 and I know that 92% of people said yes. So it's just a little trick there. Again, 92% of people did not vote. So this says something about the types of people that we have responding, also response bias, that people all want to say they voted, and it's 0 or 1. Okay, so we have a nice binary variable going on there. Okay, so that's how we can get some very basic summary stats. So let's say we want to know if there is a relationship. And so you go through the hypothesis testing process that we used in each of the videos. So you're going to want to go back and look and do the actual hypothesis testing process. But I'm just going to show you how to do the statistical tests on the computer here. But we're not going to walk through each one from start to finish. So make sure you never do this theoretically, except that I am doing that now. Okay, so let's say we want to find see if there's a relationship between two categorical or two binary variables. So for that, we want to do a crosstab. Remember, go back to our quant modules where you can see what test you use for what. And so here's how you get the computer response for a crosstab with chi-squared for two binary or two categorical variables. So I'm going to write tab, so tabulation, cross tabulation, and I have the variables government effectiveness and voted. And now I can also just write chi-squared and say I want my chi-squared test statistic. And it'll all pop up kind of like what I've shown you in class in the output. So it'll be a crosstab showing the binary variable, the categorical variable, the total number of people who responded to both questions. It'll have your chi-square, your degrees of freedom, chi-squared, and p-value. And again, we're not going to get into interpreting that because that's in the full video on crosstabs and chi-squareds. Just another fun trick with tab. If I did the same thing here and I write call, it'll tell me all the percentages as well, which is fun. So frequency and then column percentage. And this can be really helpful to like copy and paste this into an Excel document to create a really cool data visualization. So like a chart or graph or something. You can just copy table and then it'll easily go into Excel. You can make graphs and charts and all that kind of stuff in STATA, but they're kind of ugly. But this way, if you just regular copied it, let's just say I just went copy, it would all look really weird and you wouldn't be able to have the numbers separate. So this, at least you can use this then to make a cool graph or chart or whatever. So that's the crosstab and chi-squared. Let's see if we want to see a variable that is binary variable with a continuous variable or linear variable. That's our t-test. So all you have to do is t-test. We're going to do age years by voted. So here's our binary variable and here's our continuous variable. And it will give you, you may sometimes need to just make it bigger. It'll tell you the mean of the group that did not vote. So the mean of the people who didn't vote was about 48. The mean of the age of the people who did vote was about 55. And it'll tell you degrees of freedom, your T, your confidence intervals. It'll give you all this information. And again, you can go to the video to look a little bit more about how we interpret this t-test. Now, let's say you wanted to do a correlation. So that's two continuous linear variables or linear variables. So a correlation is just, I like to do a pairwise correlation because then you can get the significance. So age years with interest. And then you put sig, which gives you the significance. And so what it'll do is it'll say the correlation in like a matrix. And so it'll say the correlation here is 0.16 and our p-value is less than 0.0000, and I'm sure it's going to keep going on and on. Remember, these are just rounding. So somewhere there will be another number because we're never 100% confident. So p at least is less than 0.01. And so that'll tell you the relationship between age and, or if there's a relationship between age and political interest. There are a few different ways to show these tests graphically. So we have our chi-squared with crosstabs. We have our t-test. We have our correlation. Those are pretty much the main three you'll need access to. There are some ways that you can visualize these, but again, I tend to go for doing it in Excel because they're not that pretty. But let's just say you wanted to do, so a bar voted over government effectiveness. You can do like a little bar graph. Just may take a minute as it thinks that through. Oh, wait. So yeah, number one reason you will get a red message is you will type something. It's not cover, it's over. Make a little bar graph. And obviously these overlap. There are ways we could do a whole video on data visualization in STATA. The mean of voted based on their responses to each of these questions. Again, there wasn't much relationship going on, so you don't really see much here. But I would prefer just to do this in something like Excel. I think it would look prettier, but that's just me. You could do a box for graph box for interest over voted. So that's for this. This would be like for a t-test box plot. So it shows you like where the density of points is. It's kind of interesting. Again, I'd probably just compare means and show, because I feel like that's so much easier for people to just understand. And then the one place I might actually do a visualization on STATA itself is a scatter plot for a correlation. So two-way scatter, age, years, interest, and then I'm going to put a line of best fit just because it's pretty. Well, more than just because it's pretty, but age, years, interest. This should. Oh man, okay, so the tricky thing, of course, being that because there's only 10 points on the interest, that it ends up making it look like lines, but it'd be a scatter plot. Yeah, so when you can do visualization in STATA, it's not the best, and I tend to make everything in Excel. So I would, let's say I wanted, I'd have to work around this a little bit, streamline this graph, and then maybe do some sort of, you can go into insert recommended charts. It might suggest one, and I can help you and give you an idea of what kind of data visualization you might want to do. But that's always just a nice added touch, or to show a nice chart, again, not just copied and pasted from STATA. And again, go back to the videos on these 3 tests so that you can understand them and understand how to do them. This is just a very quick, here's how you can actually do it in STATA. Always save your do file. Okay, so that would be the 3 main tests we might be using and some data visualization, but again, probably more prettier on Excel than on STATA.